right, so this is where we left off, folks. Let's take a quick look here. Okay, we were looking at this discrete math stuff. Okay, so what is this telling us here? If we know that the sum of this first sum, the sum of a sub k, whatever that is, we don't even know what it is. It's just going to be some expression that involves k's. As k goes from 1 to n is 7, and the sum of b sub k, whatever it is, from 1 to n is 12, then what would the sum of the expression b sub k minus 3a sub k be? Anybody know? Okay, the important thing here is just going to be to recognize the properties of sums, right, using sigma notation. So what are the steps we could go through? Well, so right here, like, what did we say about when we're summing multiple terms? I split them up, right? Good. I can split them up and I can sum term by term. So the first thing I could do is I could make this the sum of b sub k minus the sum of 3a sub k. Okay. What could I do with this guy still? There's another property here, exactly, and unsurprisingly, because I'll give you a little hint here, anti-differentiation is going to end up being strongly related to what we're doing here for reasons that are very mysterious right now. But all of the stuff we can do with antiderivatives, which are essentially the same kinds of tricks we can do with derivatives, end up applying with sigma notation. So what could we do? Like if this were a derivative, what would we do with that 3? What would we do? Pull it out front, right? Or if it's an antiderivative, we'd pull it out in front of the antiderivative, right? Okay, so point being, we can do the same thing here. I can take that 3. Come, that's not. There we go. There we go. I can pull that out in front, right? And we end up getting then the sum of b sub k minus 3 times the sum of a sub k from 1 to n. And what do we know about those sums? Well, they told us what they are, right? This guy right here is 7, right? And this sum right here, they told us what that is. It's 12. And so my answer is just going to be 7 minus 3 times 12. The whole point of this question is just so you see that you can use these properties to pare this down to where the sums, I can pare this down to where the sums are really minimal. I know what they are. Yes. Oh, did I do it backwards? Yeah, I did, didn't I? Whoops. Oh, got them all backwards, darn it. So I gotta change my colors around. So this one is this guy, and this one is this guy, and my numbers are what? So I get 12 minus 3 times 7. Yes. So 12 minus 21 is -9. What do you know? How about that? Okay, give me thumbs. Does that make sense? Our logic on that? Okay. Okay, let's practice this one. Okay, so here's one where, I mean, you could add these things up. Like if you had to do this on a calculator that doesn't have access to sigma notation, right? You would have to either add up 12 terms, right? 1 cubed plus 2 cubed plus 3 cubed, etc. Or better yet, we could use, much better, we could use this summation formula, right? The sum of k cubed from 1 to n is that, okay? So what does it become here then? Okay, so I'm going to get, so n is 12, right? So it's going to be 12 squared times 13 squared divided by 4, right? And 12 squared over 4, so 144 over 4 is just 36, right? So this is just equal to 36 times 13 squared, so 169 times 36. That's not a big deal. We can multiply that out. What's that give us? What is it? 84? Okay. There it is, 6,084. What do you know? Okay, you see the huge advantage of these, right? These, as long as we know what n is, if we're summing from 1 to n, the answers to these power functions, and we only know this stuff for these 4. That's it. That's the only ones we're going to know this year for these formulas. But if I have the sum of a power function, right, then I know what the answer is going to be in terms of the upper limit of that sum, right, in terms of what the top term is. Okay. So let's do this one without technology. We know the answer is 903, I guess, but let's do this without technology. How could I do this one? And there are sort of, okay, so there are implied, there are implied brackets or parentheses around this whole thing, right? We're summing that whole expression. So what could we do? This is a really important one. You're going to be doing a lot of stuff like this. Okay, go further. What do you mean by separate them? Okay, but now when we separate them, we got to be careful about this because you could imply, there's two things that could imply, and only one of them is legitimate. You can't separate the factors, right? That's not a property we have, but you could distribute and separate the terms. See what I'm saying? Okay, so yeah, if we distribute, look what we get here. If we distribute the k, then this whole thing becomes sum of 9k squared plus 4k from 1 to 6, right? Okay, so now how are we going to use those formulas? So what do I do? I'm going to separate them. What do I do with the first one? Take the 9. Good. So I take the 9 out and I separate the two terms. Good. Good. Plus, take the 4 out, right? Good. So this first one is just that formula right there, isn't it? Agreed? This guy is that formula right there, and I just apply them. So what's that give me? So I get 9 times the sum of k squared from 1 to 6 is, what do the numbers on the top become? Good. 6 times 7 times 2 times 6 plus 1 is 13. Good. divided by 6. Good. Okay. Plus 4 times, what does this one become? Good. Okay. And so what could we do here? Well, let's see. We could, I could cancel those guys, right? And then I just get 21 times 9 is 189. Plus, I could reduce that fraction, right? And I just get 2 times 42 is 84. And so that's going to give me 173. Is that right? 273. Right? 273. Is that what we're supposed to get? What the heck? Why did we get something so far off?
I just did it. You did 7 times 13. You put it as 21.
Oh, no wonder. That was dumb, wasn't it? 7 times, okay, yeah. So that's going to give me 63 times 13. So 6. So what you guys, what is that? What's 9 times 7 times 13? 819? Okay, that's a little better. 819 plus 84 is 903. Is that what we're supposed to get? Yeah, there we go. Okay, perfect. Okay. Okay, and then how could we do this one with technology? I mean, either Desmos, that's just the stuff we did the other day, right? You would literally put that in on Desmos or on your TI-84. It'll give it to you directly, okay? All right, so then why are we doing all this stuff? You might ask yourself, why do we do any of this stuff? Well, we do it because it's math and it's awesome. That's why we do it.